So where does visual information go once it leaves the retina? It turns out that axons leaving the retina go a whole host of different places. The neural pathways that leave the eye, beginning with the optic nerve, are often collectively referred to as the retinofugal pathway, which can be translated from Latin as fleeing the retina. A significant subset of retinal projections go to a structure called the tectum, or colliculus, which is a low-level brain structure situated atop the brainstem. We call this projection the retinotectal projection. The tectum is an ancient structure that's also found in many of our more distant evolutionary cousins, such as reptiles. The tectum is involved in orienting to stimuli in the environment. For instance, when something suddenly appears in the environment and we involuntarily move our eyes and head to look at it. Other retinal axons go to other smaller nuclei in the brain, such as the accessory optic system. These nuclei are involved in involuntary reflexes, such as the optokinetic reflex we mentioned earlier. You can think of much of what the accessory optic system does as analogous to the vibration reduction system on a fancy modern camera lens. It's a tight, closed-loop system for moving the eyes so that we have a crisp image even when the world or our head moves rapidly. Another major projection goes to the thalamus, a key way station in the middle of the brain, which then projects onto the cerebral cortex, the folded-up tissue covering the outside of the brain. A great deal of processing happens in our visual cortex, and our conscious perception of vision resides here, so we'll spend the rest of the lesson talking about this special pathway in the brain. Let's take a tour of the visual system and follow the flow of visual information from the eye through the middle of the brain to the specialized area of the brain that deals with vision, the visual cortex. The retinofugal projection has 5 major parts before reaching the visual cortex, which in order include the optic nerve, the optic chiasm, the optic tract, the lateral geniculate nucleus, and the optic radiation. We begin our journey with the optic nerve. The optic nerve is a bundle of nerve fibers leaving each retina. Interestingly, the input from the left visual field is ultimately destined for the visual cortex in the right cortical hemisphere, and vice versa for the right visual field. Nerves actually cross from right to left and left to right before continuing on. Interestingly, this crossing isn't a matter of the left eye going to the right side of the brain and the right eye going to the left side. Because the right side of each retina sees the left side of the visual field, and the left side of each eye sees the right side of the visual field, the crossing is actually quite a bit more complex, with half retinas, hemiretinae, separating out and crossing each other, or not, as appropriate. All of this crossing happens in a structure called the optic chiasm, where nerves from both eyes combine. This crossing of a fiber bundle from one side of the brain to the other is called a decussation. Following this decussation at the optic chiasm, the axons of the retinofugal projections form the optic tracts, which on each side of the brain follow into specialized structure located in the thalamus of the brain called the lateral geniculate nucleus, or LGN. From the LGN, the path continues in the right and left hemisphere via the optic radiations to the right and left visual cortex, the central processing area of most visual information. In the next few lessons, we'll stop over in each of these areas and look at their distinctive properties.